In this video, we are going to practice verifying identities such as this one. Throughout the video, I am going to assume that you have either memorized the Pythagorean identities on this paper, or you should be able to create a chart like this within about a minute and a half. So, looking at problem number 1. I see that we have secant squared minus 1. Let's see if that's on the chart, first of all. Okay, here's secant squared minus 1 right here. So that equals tangent squared. So let's make that substitution. So, making the substitution, this is tangent squared. So that leaves me with tangent squared times cosine squared is equal to sine squared theta. So you can only work on one side of the equation or the other. I recommend picking the more complicated side and then transforming it to make it look like the simpler looking side. So what do we have? Tangent squared theta, that's the same thing as sine squared theta over cosine squared theta. All right, so that is times cosine squared theta over 1. And the cosine squared theta cancels out. So that just leaves you with sine squared theta equals sine squared theta. So there we have verified the identity. So looking at this one, the more complicated side is the left-hand side, so I'm going to work on that. I notice that I have tangent theta in both terms, so GCF, I'm going to factor out the tangent theta. That will leave behind cosecant squared theta minus 1. Let's see if that is on the chart, cosecant squared minus 1. Okay, so here it is in blue, cosecant squared minus 1. That is cotangent squared. So let's make that substitution. So this will be cotangent squared theta. Well, I don't really need the parentheses, do I? All right, so I have tangent theta times cotangent squared theta is equal to cotangent theta. Now, cotangent is cosine over sine. So this is cosine squared theta over sine squared theta. Meanwhile, tangent is sine over cosine. All right, so one of these sines will cancel out one of this sign in the top will cancel out one of the signs in the denominator. You know what, so I'm just going to show an extra step here. So I have sine theta over cosine theta. Okay, now this is cosine theta times cosine theta. And sine squared theta is sine theta times sine theta. Okay, so what's really happening is sine theta is going to cancel out sine theta, and cosine theta is going to cancel out cosine theta. So that makes it really obvious that's what's left is cosine theta over sine theta, which of course is cotangent theta. Okay, and that is what we were trying to prove the whole time. So cotangent theta is equal to cotangent theta. So we have proven the identity. All right, take a look at number 13. Again, I see a common factor, so I'm going to factor out sine theta. That will leave behind 1 minus cosine squared theta is equal to sine cubed theta. I wonder if this is on that chart. Okay, so I have 1 minus cosine squared. That is sine squared. So I can make that substitution and put sine squared theta right in here. So this is sine theta times sine squared theta. So that is sine cubed theta. So that is what we were trying to verify. Okay, how about number 14? Well, whenever you have a fraction, it's usually you want to get like denominators and add those together. So in this case, I'm going to need to multiply by cosine in the numerator and denominator here, and multiply by sine theta in the numerator and denominator here. That way I will have cosine, sine, cosine, sine. The denominators are now the same. So that is going to give me cosine theta secant theta. All right, I'm just checking things out. So that's going to give me cosine theta secant theta, okay, minus sine squared theta. Go ahead and I'm putting that together. Over cosine theta sine theta. And I'm trying to verify that that's equal to cotangent theta. Well, secant is the reciprocal of cosine. So this is really cosine theta, okay, times 1 over cosine theta. And then I've got the rest of it. Okay, but these cosine thetas are going to cancel each other out and just leave 1 minus sine squared theta. So that's what I have in the numerator now, 1 minus sine squared theta over cosine theta sine theta. Now this looks like something off the chart. 1 minus sine squared theta is equal to cosine squared theta. So now I have cosine squared theta over cosine theta sine theta. Okay, so this cosine is going to cancel out one of these cosines. So that's just going to leave cosine theta in the numerator. Okay, so that's going to leave cosine theta over sine theta, which is the definition of cotangent theta. Now hopefully that's what we were trying to verify. And yes, it is. So cotangent theta equals cotangent theta, and we have officially verified the identity. Okay, and now this is transitioning over into solving equations. So I think I'll go ahead and stop the video here. I hope it was helpful, and I will see you on the next video for solving equations.